Okay, greetings students. This is going to be a video on how to solve a nonlinear equation. So from the Hanna book, in the crank effort diagram, there is an equation to solve, and the equation takes the form 2100 sine of theta plus 900 sine of 2 theta is equal to 549.3 for theta between 0 degrees and 360 degrees. The objective is to find theta. So you can do that by defining a function of theta to be 0. So that's a function of theta. I took the left-hand side, I subtracted the right-hand side, and then that would be 0. So the problem is find theta such that f of theta is equal to 0. That is basically the problem. So you can tabulate some values of theta. In a table. So if I'm taking 10 values, it would be 0 degrees, 36 degrees, and so on and so forth. So we can just work it out quickly. Right, so it would be 0 degrees, 36 degrees, 72, 108, 144, 180, 216, 252, 288, and 360. So I've taken the range from 0 degrees to 360 degrees. I've taken 10 points in between, and then I want to work out the value for f of theta, which is 2100 times sine of theta plus 900 times sine of 2 theta minus 549.3. So I need to work out the value, and then I'll tabulate the values. So when we do that, and we calculate it with the pocket calculator, we get minus 549.3, 1686.8, 1826.8, 489.9 minus 409.5 minus 689.0 minus 155 minus 158.3 minus 2925.2 minus 2785.4 and minus 549.3. Okay, so I have an equation 2100 sine theta plus 900 sine of 2 theta is equal to 549.3. Find the value of theta. I took the left hand side and I took the right hand side and I put it all on one side. That would be equal to 0. So I said let the function f of theta be left hand side minus the right hand side. That is equal to 0. Find the value of theta in that equation. Theta is between 0 degrees and 360 degrees. So I took 10 points from 0 degrees to 360 degrees and I tabulated the value of the function of the angle. And it would be minus 549, 1686, so on and so forth. We want to find the value where it is equal to 0. So we see that this is a negative minus 549 and this is positive 1689. And then there is a value of positive 489 and minus 409. So between the negative and the positive, there's going to be some value of theta. And between the positive and the negative, there's going to be some other value of theta. So because it's a smooth function, as it goes from a negative to a positive, there would be a value of 0 somewhere in between as it moves from negative to positive, and as it moves from positive to negative, there would be some value of 0 between the positive and the negative. So what you do is you bracket the term between a negative and a positive, or a positive and a negative, and then that would be a 0 somewhere in that range. So we know that theta 1 is between 0 degrees and 36 degrees, and we also know that theta 2 is between 108 degrees and 144 degrees, because the negative minus 49 is with 0 degrees and the positive 1686 is at 36 degrees, and the plus 489 is at 108 degrees, and the minus 409 is at 144 degrees. So we don't know the exact value, we just know the range. So we assume, for the sake of argument, that theta 1 is approximately half the value between 0 degrees and 36 degrees, which is roughly 18 degrees, and theta 2 is approximately halfway between 108 degrees plus 144 degrees, which is, we can just work it out on the calculator. $126 degrees. Okay, now when you want to work out a root of a nonlinear equation, it is best not to use degrees, rather use radians. So theta 1 is roughly 18 degrees times, you want to convert degrees to radians, so you multiply it by pi over 180, you get an answer, and theta 2 is roughly 126 degrees times pi over 180, which is equal to, and then we work it out on the calculator quickly. .3142 and theta 2 is roughly 2.1991. Okay, so we had the equation. We took the left-hand side, we subtracted the right-hand side, that would be 0. We called it a function. We took a range of values, and where it moves from a negative to a positive or a positive to a negative, that's the approximate value for where the root is going to lie. We took the initial estimate of the root as the halfway point as it moves from a positive to a negative or a negative to a positive. So these are our initial guesses for the answer. Then we're going to use Newton's method. So to solve, f of theta is equal to 0. The estimate would be some initial estimate minus the function of the initial estimate divided by the derivative of the initial estimate. So we have f of theta is equal to 2100 sine of theta plus 900 sine of 2 theta minus 549.3. Therefore, the derivative of f of theta, derivative of sine is cos, so it is 2100 cos of theta. Derivative of sine of 2 theta is cos of 2 theta times 2, so that would be 1800 cos of 2 theta, and the derivative of a constant is just 0. So we then say theta 1, we give our initial estimate as 0, and then theta 1, the first estimate is what we worked out to be 18 degrees, which is 0.3142 radians. 0.3142 radians. Then f of 0.3142 radians is equal to, and this is our function. Now we need to work it out. Can work that out in a moment. Uh, 628.78, and then the derivative of the value. We then work it out again. Three one 42. It's 3,400. 3,453.2. Then the next estimate would be theta 1 next estimate is equal to the initial guess, which is 0.3142 minus the value at the angle 628.78 divided by the f primed 3453.2, and then that would give you your next estimate, which we will work out. 3142 minus 628.78 divided by 3453.2, and then that would give you a value of 0.1321 radians. So our initial estimate was 0.3142 radians. Then our next estimate would be 0.1321 radians. Then initial estimate was I is equal to 0. The first estimate is 0.1321. Then for I is equal to 2, the next estimate would be the previous value, 0.1321 minus the function of 0.1321, which we need to work out. That would be minus 37.673 divided by f primed of 0.1321. That would be 3,800 and 19.2, and then that would give me an answer of this minus the f primed divided this minus f of the angle divided by the derivative of the angle. So that would then be 0.1321 minus 37.673 divided by 3819.2. Then the next estimate would be 0.1420 radians. We'll repeat this a few times until we get convergence. Exactly the same thing, so we work it out. Divided by f primed at 0.1420. This is 3,806.8, which is equal to that minus that over f primed, which is 0.1420 minus 0.076743 divided by 3806.8, and it is 0.1420 radians. So it's converged. We're just converting it to degrees. Okay, and then that's the final answer for the first angle. So the textbook gives an angle of 8 degrees and 10 minutes, and we worked it out to be 8.1360 degrees. We can check it. We can say f of 0.1420 is equal to, this is the formula that we're going to substitute. So then that would be 2100 sine of 0.1420 plus 900 sine of 2 times 0.1420 minus 549.3, and then that would give me an answer Alright, so the answer is approximately 0.0767, and it is roughly 0. So we would you can continue if you want extra decimal points, but that's where we stop for the first answer. And then we repeat the same process for the second angle. So for the other angles, we do the same thing. Our initial estimate is theta to 0 is equal to 2.1991 f of 0 f of 2.1991 is equal to 2.1991. So that's 293.71 f primed of 2.1991 is equal to minus 1790.6. So it would be the previous answer minus the function at that angle divided by the f primed that would then give you an answer of 2.3631. Then the next approximation is the previous answer f of the angle divided by f primed of the angle. F primed of 2.3631 we just work it out. So now we're going to work out a third approximation. The function of 2.3804 divided by f primed at 2.3804. So we get into convergence. Our initial estimate was 2.1991. Then we refined it to be 2.1991. And that gives you 2.3631, then 2.3804, 2.3806. So we get into convergence. We'll take a fourth approximation and then we'll stop. Okay, so we can stop over there. That's reached convergence. And then the answer is theta 2 is equal to 2.3806 radians, which is equal to 2.3806 times 180 over pi, which is equal to 2.3806 times 180 over pi, which is 136.40 degrees. So when you're working out a nonlinear equation, you have some complicated equation. You then say the left-hand side, subtract the right-hand side. That's going to give you some function of the variable. You tabulate some parameters in the range, typically 5 or 10 points in the range. You check where it goes from negative to positive or positive to negative. The root is somewhere in that range. You take the midpoint as an initial estimate. You have your function. You take your derivative of the function using calculus, and then you apply Newton's method, that you take the refinement of the root is the initial root minus the function of the root divided by the derivative of the root. And then you tabulate. So you say I is equal to 0. It's your initial estimate, first estimate, the second estimate, the third estimate. And then you check whether it gets to convergence. And then for the other point, you take an initial estimate. You apply the approximation, the first estimate, the second, third, and fourth, and so on and so forth. And eventually you check when it gets to convergence. And if you're happy with the number of decimal places, then you stop. So typically you do this for 2, 3, maybe 4 iterations. And that's how you solve a nonlinear equation using Newton's method. So make the function to be 0. Left-hand side minus right-hand side is equal to 0. Tabulate a few values. Check where it brackets negative to positive or positive to negative. Take that in midpoint as the initial estimate. And then you apply the Newton's equation. This is the Newton method. So that's Newton's method to solve a nonlinear equation. And I think that's where we will stop the presentation. Thank you very much and keep well. Bye.